Okay, so the side splitter theorem says if I have two parallel lines, like we do here, and they intersect the two parallel lines intersect two other sides of a triangle, then it divvies up the sides proportionally. So I'm going to write down some proportions, and hopefully you can see how this will be helpful. So this side QT, the way these split it up over SU is going to be equal to TR over UR. And the cool thing is, even the entire side over a piece of the side is going to be proportional. So you can say QT, so this distance here, over the entire distance QR is proportional to SU, so it's matching guy on the other side, over the entire length of that bottom side, SR. And then the last proportion we can write is this side TR over the entire side QR. It's going to be proportional to its matching buddy UR over the entire side SR. And I don't think you'll need any other proportions out of that than those ones.
You missed a spot.
The converse of the side splitter theorem says if I have two sides that are proportion, then it is parallel to that third side. So you can work your way backwards. If you can declare any of these proportionality statements, if you can declare that first proportionality statement, then you can say that the two lines are parallel. So when we look at example 1, we want to find the distance EC. So I'm going to make that into an X. So there are two different ways we can do this. We can do this using the entire side. So we can say that for the little piece over the entire side, 12, is equal to this little piece X over the entire side, X plus 12. That's one way we can do it, using the entire side length. So then we get 4x plus 48 when we cross multiply equals 12x. Now we're solving for x. We subtract 4x from both sides. We get 48 equals 8x. We divide both sides by 8. Sorry, my brain was skipping to the answer. We'll throw to 6 there. And we get x is equal to 6. This is using the big triangle. We can do this same problem using just the pieces. So I can say that for this little piece here, 4 over x, this other little piece, is equal to 8 over 12. The little, actually, it looks little, but this is obviously not drawn to proportion, to scale. So then we we'll do our cross products. 4 times 12 is 48, and x times 8 is 8x, and it's essentially the same thing. And 6 is equal to x. So be flexible. You may not be using the same method as somebody else in your group, but you will get to the same answer if you're doing it correctly. Okay, we're going to answer this question in example 2. Are these lines parallel. So we are going to have to set up a proportion. So is QT, which is for us is like 21, over SU, which is 16, equal to TR, which is 56, over UR, which is 40. Are those two guys equal? So we have to reduce, reduce, reduce. By the way, this skill of reducing to lowest form, simplest terms, is something you'll have to do in your performance test. 21 over 16, it's not, 21 isn't even, so I can't cut it in half. 16 is, and 16 is just multiples of 2, so that doesn't quite work right. But I can, so 21 over 16 is in lowest terms. 56 over 48. Now we can 8 goes into 56. Divide by 8. 56 divided by 8 is 7. And 48 divided by 8 is 6. Is 21/16 equal to 7/8? 7/6. So it's no. That means it's not parallel. Any questions on that, guys? Okay. Alrighty, so let's look at example 3. We have 15, and he matches up with 9. And 15 is the base of this big triangle. So what is this bottom side of this big triangle? Whole distance here. Yeah, so it's going to be 9 plus x. Do not be fooled. Do not just put 9 down. So then it's this whole side length over this little guy right here. Little distance there. So we cross multiply, we get 15x equals 81 plus 9x. We subtract 9x's from both sides, and we get 6x equals 81. I divide 81 by 6, and through the magic of, I already did this ahead of time, we get 13.5. All right, example 4. We're going to take this little piece here, x, and put him over. I want to use the same process that I use up here. Okay. Looking again. QT over SU, so the matching part. Okay. So we're going to go x over 12 should equal x plus 4 over 18. Colors. Do your cross products property, and you get 18x equals 12x plus 48. And then we subtract 12 from both sides. 12x's. 12x's from both sides. We get 6x equals 48. And x is equal to 8. Oh my goodness. Last page. This is super exciting. Last page of the splitter. Okay, so it's 3 parallel lines. So now we just don't have a triangle. We have another line. It's going to be parallel to the first 2. It's going to divvy our sections up proportionally. So if this little distance here was A, this little distance here was B, that little distance there is C, that little distance there is D, it would divvy these up proportionally. So it would be like A, C is equal to B, D. So it doesn't have to be a triangle. This works with 2 lines hanging out, cutting across the perpendicular parallel lines. The same rule applies as well. The entire distance, so like A, so if I wanted to say that A plus B over C plus D is equal to A over C. So you can use the entire length as one of your proportions. So that would be A plus B, and then C plus D. You can also say I added a 4th parallel line, and this was E and F. You can even say that E over F is proportional to B over D. So you can even skip, you don't even have to write the AC part on it. It's proportional to AC as well, but you can skip over that, and which you're going to have to do for your practice assignment. And you can say that they're proportional. So even just 2 parallel lines can be proportional. For Theorem 7.5, if you have a ray that's bisecting an angle of a triangle, it divides the opposite sides into segments whose lengths are proportional. So I would like you to go ahead and circle the proportional statement so that when and if we need this, you can go back to it and you don't have to memorize it. All right, let's use those 2 properties to do examples 5 and 6. In example 5, we want to find ST, so I'm going to let it equal X. So we can say 15 over X is equal to 9 over 11. And that's 9X equals 165. Not because I have my 15s memorized, but because I did it ahead of time. Then we want to divide both sides by 9. 165 divided by 9 is 18 and 1/3. No calculator needed. Okay, so let's look. Any questions on finding ST? Okay, so let's look at our second example. We want to find AD, which is this guy right here. So we're going to use that proportion up there. It says AD, which is X, over DB, which is 10, is equal to CA, which in our case is 9, over CD, which is 15. When we do our cross multiplication, we get 90 equals 15x. Divide both sides by 15. And we get x is equal to 6. That is it. Done and done.